Now let's look at the situation where you start with the formula of an ionic compound that contains a polyatomic ion, and you need to go backwards to the name. This is really easy. Basically, you just look it up. It's really nice. Let's start with this one right here, KCH3CO2. This is the first one on our packet assignment. KCH3CO2, and I have to confess, when I wrote this packet, I didn't write this the exact same way that is on our periodic table. So what I want you to do first is change this to KC2H3O2. And the name of the game here is first to realize that there's a dividing line between the two sides of this compound. There's the cation, that's the positive first half. That's the potassium. And there's the anion, which for the purposes of this video is always going to be a polyatomic anion. So this whole big clump, that's the negative side. So all I have to do really is write the names of these two things. K, of course, is potassium. And then C2H3O2, what's that? Well, we have lists available to us. You can look down all these formulas and find it, and you will see C2H3O2 right here is acetate. So we just write the word acetate and we're done. Potassium acetate, that's the formula. Pretty slick. I'll do another example real quick, but these really aren't that big of a deal. The next one here is Mg3PO42. Again, recognize that there's a front and a back. The front here is the magnesium. The back is the PO4. So Mg we know is magnesium. If you don't know that, of course, you can look it up on the periodic table. And then we look for PO4. Now, some students, when they see PO4 2 on the outside, they go to their list and they see, well, look, there's PO4, but it doesn't have a 2 on the outside, it has a 3. Well, those mean different things, okay? The 2 just means that there are 2 PO4s, and if we were to draw out the picture of this, we would find that there would be 2 of these PO4 clumps, just like we had 2 different NO3 clumps up here, right? So if we drew out the picture, we would have needed 2 of them. So you don't need to pay attention to that right now for the name. You're just looking for PO4. And then a student will ask, well, why does it say 3 negative right there? Well, that's just the charge. That's just telling you that phosphate needs to accept 3 electrons if I were to draw the picture, the Lewis structure. So really all I care about here is that PO4 right there, and PO4 is phosphate. So don't overthink it. There's a lot of extra cabbage hanging on the outside of a polyatomic formula, okay, and you just need to pay attention to what's important, which is what's in the parentheses right there. So magnesium phosphate is the answer, by the way. Last thing I want to note, there is one special polyatomic ion that you will run into, and that's way at the end here. You'll notice it's in bold. It's the only one with a positive charge. NH4 plus is the ammonium ion. And the thing about an ion with a positive charge is it means that that donates. So this ammonium ion is pretending to be an alkali metal, right? It donates 1 electron. There are no metals in it, but it acts like one. So that's kind of a special circumstance. And I think that shows up on this worksheet somewhere. There it is, NH4OH. If you ever see NH4, that should set off a light bulb in your head that that is the dividing line. We've got NH4 in front, which I just said is ammonium. And then OH, that's another polyatomic ion. We will dig that up. Looking, looking, looking. There it is. OH is hydroxide. Okay, ammonium hydroxide. Done. Just for fun, here's the picture. You don't need to do this, but this is what it looks like. Hydroxide is a polyatomic ion clump. It has a -1. I looked that up right here, OH minus. NH4 plus is ammonium. That means one electron goes from here to hydroxide. Okay, this is my version of the picture. Okay, we're done. Finish off that packet.